In this video, we're going to look at the final way of finding volumes, and really this is called the washer method. It's just when there's a hole in the volume you're finding. All right, so how would you find this region? So let's just say we had this region that we want to rotate around the x-axis. All right, you can see when you rotate, you're going to get this kind of empty space in the middle, and then this rotates and gives you kind of a shell on the outside. So you can kind of think about this one would actually be a bowl. All right, as this rotates around, you're going to get the outside part of your bowl and that gap in the middle. All right, how are you going to find this volume? We're going to do this very similar to how we found areas between curves before. We can find the volume of the full solid bowl and then subtract away the part we don't want, the inside of the bowl, and that's going to give us that shell that we actually want. So just like we did when we were finding areas between curves, we basically just subtract away the area we don't want after we find the full area. All right, that's going to give us this equation. So pi r squared for the full outside area, subtract away the inside area we don't want, that's another pi r squared. This pi just got factored out, that's why it's just 1 at the front. All right, but similar to how we find areas between curves, just take the outside part, subtract the inside part. Again, we're just going to focus mainly on creating the equations. All right, let's say we had this region. We have y equals x squared and y equals x, and it creates this region here. I'm going to rotate that around the x-axis, but you see there's a gap here, so it's going to create a kind of central space that's not existing in this equation. So when we take our formula, it starts at 0, it's up at 1, we have pi. The outside radius, in this case the bigger radius, is going to be that blue graph, which is x, and we're going to subtract off the inner one, like that. All right, so that's our formula. All right, exactly like when we were finding areas between curves, but now we're just mixing it in with these rotations. So the integral from 0 to 1 of pi times x squared minus x to the 4th dx, and that is 0.419. All right, again, this one is another one you could solve by hand, but that's not what we're focusing on mainly right now. All right, this one we're rotating about the y-axis. We have x equals y squared, which is going to be this sideways parabola again, going this way. And x equals y cubed, which is the x cubed graph, but turned like that. It's kind of hard to see because I didn't draw the graph perfectly, but there's a little region in here that we're going to rotate around the y-axis. And again, you can see there's a gap between the y-axis. So what is our integral going to be? All right, our integral starts at 0 and ends at 1. All right, pi times the 2 radiuses squared. All right, the bigger radius is the one that's on the right. All right, and actually, by the way, I drew it looks like y cubed. If you were to use a graphing calculator, actually y squared is on the right, so that's actually going to go first. Then we subtract the one that was on the left, y cubed. Okay. All right, so this one, all right, my graph isn't great, so let's actually just try to draw it a little bit better that we can actually see. All right, we have y squared. That was terrible. We have y squared, and then y cubed. Looks like that. There we go. All right, so that's better. So this is what our graph actually looks like. So we have this tiny region, and on the right is the y squared one. All right, so this is not a good graph. All right, but that's our setup for our integral. Same thing, pi r squared is the area of a circle, and the integral just adds up all these circles together. All right, so this one we have y equals x squared, y equals 4x, and then y equals -2. So let's try to graph this. All right, y equals x squared is our parabola. Y equals 4x is a line. And y equals -2. I'm guessing that's where those two things are already crossing, but let's just double check. Oops. Oh, no, they actually don't cross at -2. So -2 is about here. And we just have this region that's kind of cut off. Oh, I messed up. So it's not the line y equals 2, it's rotated around the line y equals -2. All right, so we had this full region here, and we're going to rotate it around this line. So now we're going to have this big gap as we rotate this all the way around. It's going to create this outer shell with a big hole in the middle. But nothing's really going to change. Where's my area or my region start? It starts at 0. Where does it end? It ends when these two things are equal, which is at 4. All right, pi times the radiuses, the bigger radius squared minus the smaller radius squared. All right, so now you can figure out what are these radius. Well, the bigger radius is going to be from this green line, which is 4x, and I have to add extra to it because it's getting bigger. So I'm going to take 4x, I'm going to add 2 to it, because instead of rotating just around the x-axis, I'm rotating around -2, so I have a bigger radius there. Then my smaller radius is the same thing, x squared, but I have to add 2 to it to make up for the fact that there's this gap here that's not there. All right, so this is the integral that you'd have to do for this example. So even though it's not rotating around an axis, we still do it the same way, pi r squared for both of the bigger and smaller radius. All right, so here's one for you to try on your own. All right, R is the region bounded by y equals 4 minus x squared and 2 plus x squared. All right, what is the volume when it's generated or revolved around the x-axis? All right, so go ahead and pause the video and try this one on your own. And the answer you get should look something like this. All right, so drawing 4 minus x squared is this upside down parabola, 2 plus x squared is this normal parabola. All right, so our region starts at -1 and ends at 1. All right, pi r squared, so pi, the bigger radius, is going out to the blue graph, which is the upside down parabola. The smaller radius is going up to the green graph, which is the smaller radius. All right, so again, same thing, bigger radius minus smaller radius will give us the area of this rotated solid. All right, so in class, we're going to practice finding volumes of many different solids, whether they have cross sections or they're rotating around an axis.